Hi everyone, I'm going to be presenting today on chords in a circle. A chord in a circle is a segment with endpoints on the circle. I want to investigate if there's any kind of relationship between the chord of a circle and a segment joining the chord to the center of the circle. So the first thing I'm going to do is to construct a circle. Here Okay, I have constructed a circle center E, circle EF. The next thing I'm going to do is to construct a segment between or from point F to any point on the circle, and that's going to form my chord. So I'm going to get a segment from here, and I'm going to just construct from point F over there. That is my point G. I'm just going to move my circle a little bit down. Yeah, that way. Okay. Now I'm going to find the midpoint of this chord GF. And when I find the midpoint, I'm going to construct a segment to join it to the center of the circle. So to find my midpoint, I come over here and click on the midpoint or center of a line. Actually, if I click on any part of this line, it would give me my midpoint. Exactly, the point H is my midpoint. And now I'm going to construct a perpendicular line to join my midpoint, the midpoint of the chord to the center of the circle. There. Alright, so the midpoint is now joined to the center of the circle. I'm now going to move the circle around and then I'll make some observations. Okay, I'm moving point G around and I can see some relationship already. I see the chord getting longer and the segment joining the center of the circle to the chord is getting shorter. Okay, before I go ahead, I'd like to get rid of this point, this perpendicular line, but I still want to maintain the line joining the midpoint H to center E. So to do that, I'm going to construct a segment from point E to point H, and then I can hide my perpendicular line. Alright. Okay, so to check or investigate the relationship between the chord CGF and segment EH, I'm going to have to measure this distance, the lines, and then I will drag point G around the circle to make my conjectures. Okay, so if I can just hide what I've done so far to save time and bring up a circle I have already constructed there and there. Okay. I'm now going to take the measurements, measure the distance of the length, point C and B, and point A to B. Alright. So now I know my CB is 6.02 and my AD is 2.99. I start to move it round now, and I can already notice, visually we can see the chord getting longer, and the distance definitely is getting longer, while the segment joining center A to D is getting shorter. I keep moving and I'm recording different lengths as I move on. This point is really interesting. Point AD is now 0.02, is almost 0, while chord CB is 8.49. If I try to drag point C further down, I see the line CB reducing again. If I take it back, it's also reducing. So when the midpoint D overlaps the center point A, I realize the chord CB is at its longest, which therefore is the diameter of this circle, because the diameter is actually the longest length of the chord in a circle. Okay. I have recorded some points for CB and AD. Now I'm just going to drag it out this way. Okay. I want to show a graphical representation of these relationships to further come up with more conjectures. So all the points here, all the way down, is CB, while the second column is AD. I tried to make the circle bigger, and I've recorded all the points, all the different points lengths. So now I'm going to find the X and Y coordinates. Say equal to, okay, open CB and AD. Now I should drag this all the way down. Okay, let's drag down. Wow. Okay, so this is the curve I have made from the chord and the segment. I would like to stop here, and I will continue investigating in my next video. Thank you.